So hello everyone. So today I'll be explaining you guys about a diaphragm. So what is diaphragm? What is the role of diaphragm? So what happens is for every body right now we can see a building in here, and for every building there is a plan diagram like this. And when there is a load acting on it, there should be a way of transferring the load, right? So whenever the load is acting on this, the load should transfer in one way or something like that. So what happens is there is something called as imaginary line where at one point there will be center of mass, that is mass will be lumped here, that is called as diaphragm. So what is the role of it? Whenever there is a load acting, that is maybe let's take as earthquake right now. When building shakes, building shakes because of earthquake, mass in the building, there is a mass here. Due to that, inertia force is created. So as you guys know that earthquake is a inertial force. So due to that, this happens. Now, the force must travel safely down through the structure to the foundation and soil. That is correct. Because whatever the load is acting, whatever the case it is, load should transfer to the bottom area. And there should be a clear path. There shouldn't be any kind of hindering point that is in the building. And in the path, because of that, broken, weak, if the path is broken or weak, it may damage the building. Because if the load is not transferring to these areas, imagine if it is not transferring, it will damage this area, this column. Maybe if this is not transferring to this one, it will damage this slab. That is how it works. So you should be very careful whenever you construct a building. Now, what are the parts from load path, like form the load path? How it normally works is, as I've told you that this is a plan area, and there is something called as shear wall, as you guys know. So now imagine this shear wall is called as vertical element, and this is called as horizontal element. And usually what happens, even the columns what you guys see, right, that is a vertical element. And horizontal elements will have diaphragms, so horizontal diaphragms, and vertical will have vertical diaphragms. That is what it is called as. So horizontal beams during earthquakes, so what happens is these collect the loads. Like what happens when the load acts, these collect the loads, and through that the loads will be transferred to the vertical element. See, horizontal diaphragm and sends to the foundation. These collect what vertical elements collects the load from the horizontal diaphragm, then send it to the foundation. These can be of three types, like moment resisting frames, brace frames, shear walls. Shear walls is a very important key when it comes to earthquake resistance. Yeah, and horizontal element, remember that you should avoid big openings. All those things, the extra things, whatever is there, no, like advanced thing, I'll be explaining that in the future classes. So don't worry. Okay, so we'll not go deep into that. Just understand what is diaphragm. Now in connections, these are steel connections. What normally happens is if there is a steel connection here, so here the load should be transferred. If the load should be transferred, these should be connected, well connected. I mean, it should be strong enough and continuous. See, whatever it is, the load will transfer only if the material is continuous. So what happens if the load is transferring? Sorry, load is transferring. If you want the load to be transferred, there is a pull here. It should be connected thoroughly, right? It should be connected, only then the load will be transferred. If there is no connection, imagine like this. What is the point? There won't be any kind of a load transfer. That is how it works. And there should be any kind of a weak joints. Remember that. Now, diaphragms. See, in 1893, they have mentioned about this one. 2016, they have mentioned about diaphragms whose slow diaphragm can't be provided. Like rigid horizontal diaphragms are ones where the it will be not that flexible. Like example, this is a beam. and the load is acting, example, the load is acting like this, and if the load is acting, there will be some kind of a deformation. That is true, right? Whatever it is, there is a deformation. And if the deformation is such a way that such an extreme that this, whatever the one axis, delta 1 and delta 2, if you average it in one place, and if the middle deformation is more than the average deformation, that means that it is flexible. That is flexible flow diagram is used. If it is not, if it is strong enough, it is having a capacity to resist the deformation, then it is called as rigid horizontal diaphragms. So, as here I also mentioned, diaphragms that are designed to transfer lateral loads without any deformation. Here it is, these are diaphragms that are designed to undergo deformation. So, undergo deformation is this. Now, in prefabricated and precast elements, we take it to be a rigid diaphragm action, providing the diaphragm action. That is how it is considered to be. Now, as you guys know that in Etabs there are a lot of softwares that we work on. Now I'll be explaining in Etabs and the other one is Staad Pro. How do we apply diaphragms? Here in the definition option we have something called as defined diaphragm, where we can modify it. As I've explained you guys, rigid and semi-rigid. So what happens is there is something called as rigid at first, then semi-rigid, rigid, and then comes as one flexible. Flexible. We normally don't consider to be flexible. We don't even consider semi-rigid. We consider slab to be rigid enough because it is well strong enough to transfer the load. That is why slabs are strong enough to transfer the load. That is the reason we construct slabs. Remember that. Because normally when it comes to rigid diaphragms, so what happens is we consider these reinforced concrete slabs. Okay. When it comes to flexible diaphragm, it is mostly like we consider wood or steel constructed floors, something like that, framed floors. So those are the flexible diaphragm. Now in ETABS, what happens is here this point. Here, example, I'm going to select this slab, whatever the slabs you can see here, right? You need to select everything, then give it a rigid, apply the diaphragm here. By once you apply that, then you can understand this is the center of mass and the load will be distributed to this area. So this is how we define it. So when the load is acting, the inertia force, due to the inertial force, there will be a movement in the structure. That means there will be movement. There will be movement. Like example, there will be movement. This is how it works. So those lumped mass element, this is the movement that is happening here. Yeah. So this is one thing, Etabs. Then in Staad Pro, it works like what happens is we need to select nodes at first. So nodes, example, these are the nodes. So once you select the nodes, there is something called a specification option in Staad. There you go with the node. Then select nodes, then select the range minimum to maximum, whatever it is, maximum floor range. So as per that, we go with it. So that is how it's going to work. Normally what happens is to the y direction, whatever is there, no? We select all the nodes, we give the minimum range from this to this. That is how it's going to work. Yeah. So now as you guys have understood what is how the diaphragm works in ETABS and the Staad Pro, there's one more question that may arise in your mind, that is how will the load transfer? Like how will the load transfer in see, when it comes to a rectangular or normal shaped building, that is fine. When, if example, if there is a irregular structure, what do you think? How the load will be transferred? So, to understand that, in the future classes, I'll be explaining you guys how that will be done. So, we'll go into advance of that. So, right now, I'll be ending the class now. If you felt the video was useful, please do like, share, and subscribe. And please be like stay tuned for the next updates. Thank you.